In Chapter 1, when discussing our 3 of 3, one of our 3s were the 3 control structures. The 3 control structures were sequential, selection, or decision statement, and then repetition statement. In this chapter, we're going to look at repetition statements. Repetition statements are usually accomplished by using loops. Loops are bits of code that repeat based on a certain condition. Each time the loop's code is repeated, it's known as an iteration. One pass through a loop is an iteration. If a loop loops 5 times, we can say that that loop iterated 5 times. Let's look at some flowcharts related to loops. This is an example of a pretest loop. A pretest loop is a loop in which the test condition, is tested before the loop's body. So in this case, we ask the condition. If it is yes, we do some code, and then we change something about the condition and start over in our loop. The test condition is executed again. If the condition is true, we do something, change something about the condition, and keep doing that loop until the condition is false. Once the condition is false, it exits the loop. A prime example of a pretest loop in JavaScript is the while loop. The while loop starts with the keyword while and then a test condition, just like the test conditions that we wrote in the last chapter. A set of curly brackets will recognize the loop's body, so our loop's body is contained within a set of curly brackets. And then we have the code statements that we want to do in this loop, and then we need to change something about the test condition. If we have a pretest loop, it would stand to reason that we also have a post-test loop. In a post-test loop, the condition is tested after the loop's body. We'll do something, change something about the condition, and then check the condition. If the condition is true, then we loop again. Do something, change something about the condition, check the condition again, loop again. We keep that loop-de-loop until the condition is false, and then we exit the loop. In JavaScript, the post-test loop is the do-while loop. We use the keyword do, a set of curly brackets that contain our code statements and what we want to change about the test condition. Then we have the keyword while and our test condition. Now, what's the big difference between the pretest and the post-test loop? Well, since the post-test loop doesn't check the condition until the end, it always iterates at least one time. If the test condition is false, it doesn't know the test condition is false until it does the loop's body. So it will always do something, change something about the condition. Whatever you have in your loop body statements, it will always do that at least once, regardless of whether the test condition is true or false. In a pretest loop, the condition must be true in order for this code to ever execute. Now that we're looking at loops, there's some other things that we need to be aware of, some secondary information, if you will. Since we usually need to change something about the test condition, one way that we can do that is with a counter variable. Counter variables are often used in loops to help us kind of keep track of something so that we can change something about the test condition. If we count up with our counter variable, this is known as an increment. And if we count down in our counter variable, this is known as a decrement. Counter variables in the languages that we learn in our courses usually are a letter I, a lowercase letter I. I will not be using the letter I in this demonstration though. I'm using PowerPoint, and every time I type a lowercase I, PowerPoint tries to capitalize it because it thinks I'm using I like I am saying this right now instead of I as a programming variable. So I'll be using J in this tutorial, but in the code we'll usually use I. It doesn't have to be called I, it could be called anything, but it's often called I. Another thing that will help us, since we often have to increment our count up, which is usually addition, or decrement and count down, which is usually subtraction, then we need to be aware of shortcut operators. Now, I could have easily put the shortcut operators in chapter 1, but I wanted to give us a chance to absorb a little information before we got to this point. Shortcut operators are used to shorten some of our longer code statements. They can't always be used, but when they are used, it does help save us some keystrokes. And at least you need to be able to recognize what these are if others have used that in their code. This would be an example of what shortcut operators would look like in your code if the shortcut operators were using a counter variable of j. So it could be something like j plus plus, j minus minus, j plus equal to, j minus equal to, so on and so forth. So let's take a closer look at what these shortcut operators actually do. We're going to suppose that each individual line of code stands on its own, and starting out, j will always have a value of 4, okay? So j plus plus is the equivalent of this equation. It would be taking the value of j, adding 1 to it, and storing it back in the variable j, okay? So writing this, you can see, is a lot shorter than writing this. Plus plus adds 1 to the counter variable and stores it back into the variable. So if j had a starting value of 4, after this code executed, j would have an ending value of 5. Okay, if j plus plus added 1, then what do you think j minus minus does? Right, it's going to subtract 1. So the ending value of j minus minus would be 3. It takes the current value of 4, subtracts 1, and stores it back into j. Okay, these other shortcut operators. We have a j plus equal 2. J plus equals 2. Well, that's a little different than these others. What this does is takes the value of j, adds 2, and then stores it back into j. So it would be the equivalent of this equation. J plus 2 and then stored back into j. If j had a starting value of 4, that would mean it had an ending value of 6. J minus equal 2 would be the equivalent of j has a value of j minus 2. So if j started out at 4, after that code executed, j would be 2. All right, we've got a times equal. Same thing. You're probably catching on to the pattern here. So j times 2 stored back into j would have the ending value of 8. J divided equal to, written the long way, would look like this. And of course, 4 divided by 2 stored back would mean j had a new value of 2. And the last one is the mod equal. So we need to find the remainder of what happens when you divide 2 into 4. So the long equation would look like this. And the answer would be 0. J would have an ending value of 0. Sometimes it helps if you mentally break down these shorter operations into the long equation in your head to help figure out what the ending balance is. But just remember, your mathematical operator goes before your equal sign, and it is taking the value of the variable, doing whatever mathematical operation, whatever numerator is on the right side, numbers on the right side, and then storing it back into that variable. So see, we can take an equation like this, written the long way, we could write it a shorter way with just the plus equals. But if it was just adding 1, the shortest way would be j++. Okay, so why are we doing all this? Well, remember, counter variables are often used to change something about the test condition. Why do we need to change something about the test condition? Well, if we go back and look at one of our flowcharts, if the test condition never changes and it's always true, what's going to happen? You would be doing this over and over and over again for infinity. It's called the infinite loop. Sometimes when a test condition is poorly written or the code never changes in the test condition, your code can get caught in an infinite loop. That means the body never stops iterating and it eats up all of your computer's memory and eventually can crash your computer. Okay? So be aware when you're writing your test conditions that you may get caught in an infinite loop. Okay, your next assignment is a quiz right below this video. Once you complete the quiz, there's another tutorial where we will actually practice coding the pre-test and post-test. So good luck on your quiz and happy coding!